fresh enough in your mind that you can remember what you wrote down and what your answers were, okay? So just to start off, this is going to be out of 10. Let's go back. This is going to be out of 10 points. You get 3 points for each question. You're going to get a work point, an answer point, and then a unit point, all right? And then you're going to get 1 sig fig point overall. So if you got all the sig figs right on each one, you get that extra point to make it 10 out of 10. If you missed 1, 2, or all 3, that's just 1 point. So if you get everything right but sig figs, you should get a 9 out of 10, right? You still get an A, but it's not the 100 because sig figs still matter. But it's not going to kill you either, right? So what you should know is leaving, and I've said this, you should know this, I've said this before, leaving these questions completely blank kill your overall score. And here's why. From the beginning of the year, I told you that labels matter, right? So if you just went through and said how many grams of water, how many moles of NH3, and how many grams of oxygen, that's 3 points right there, right? So if you had no idea what to do on any of this, you could have very simply put grams H2O, moles NH3, grams of O2. And you would have got 3 out of 10 points just by doing that. No math required. You see what I'm saying? So when you get to your quiz or your test and you completely blank out, like you can still get points out of that. And it's not a 0, right? From here, if I look at number 1, here comes the real stuff. Look at number 1. Look at what I start. By the way, did anybody underline or highlight anything in this quiz? Circled or did something? Good. That's what I taught you to do, and you should be doing that. Some of you should start to do that today because of how you scored on this quiz or how you think you're going to score on this quiz because it helps, right? Specifically getting your units for your answer, right? So the big thing that you need to notice on number 1 is you're going from water to water. Why is that a big deal? It's the same compound, right? So do I need a stoic step in that? No. So what I'm saying is this was a test question from our last unit test. This was nothing new, right? So once again, if you were absent for last class, if you don't remember anything because it was a week ago, this was last unit. This was nothing new at all. So you start with, let me get rid of that line so that I just have more room to work. If you start with 6 moles, you're given, and you want to get out of moles of your given and into grams of your given, what's the conversion there?
It's 1 mole to the molar mass.
Molar mass of water, which most of you memorized, 18.016, which is why.
I realized that after.
Right? I wasn't trying to trick any of you on this. I didn't want you to spend a lot of time on something I didn't want to test, right? Which is why water and oxygen are ones that we do most often, right? So there you go. We're out of moles. We're out of moles of water. We're currently in grams of water. How do I know that I'm done converting? Because I'm in the unit that my question's asking me about, right? So I'm done, right? And now, so that's 1 point. There's your another point. Now I go to my calculated answer. If you wrote down anything like 0, 100.8, or 108 point something something, you got your calculated answer correct. But how many sig figs should I have? 1, which means your answer is 100 grams of water. Sig figs. One sig fig. But it's sig fig rules, right? So if you missed that, if you put 108, then you've already missed your sig fig count. I'm not counting it off anymore for 2 and 3. Does that make sense? It's either all or nothing. Okay? But that's how you get number 1. Number 2, we're going from moles of NH3 and into moles of oxygen. The big red flag here should be different compounds, which means I do need a stoic step. That stoic step comes from my balanced equation, which I balanced it for you. Just for your reference, on your quiz and test, some of them will be given to you completely all the way out where you don't need to do anything to. Some of them you will need to balance on your own. Some of them you will need to write out completely, predict your products, and then balance it. Like it's a stair step of difficulty. All right? They get harder as you go because the more you have to do. Okay? So from here, we start with the given, just like normal, 3.5 moles of O2. And I need to get into moles of NH3. Right? And here is what we did last time, moles of O2. Well, where can we go from moles of O2? What can we get into? But I want to end in moles. So it wouldn't make sense to get into grams of something else. You see what I'm saying? So I can go straight into moles of NH3. This was our Stoich step. This was the new conversion factor that I taught you about last class, right? Because this conversion factor comes from where? Your balanced equation. This is your molar ratio. This is something I don't think I really hit on very hard last class, but so this might be somewhat new for you guys. This kind of started our notes if you didn't notice that yet. All right. So what is the molar ratio of oxygen to ammonium? When I ask you about molar ratio, the first compound is what's on bottom. The second compound is what's found on top. So what's the molar ratio of oxygen to NH3? Where do I get those numbers from? The coefficients of your balanced equation. That's how I know what number's on top and what number's on bottom. Moles of O2 cancel out, and I'm currently in moles of NH3. Am I done converting, or do I need to go to another step?
You're done.
How do I know I'm done? That's what the question asks for, right? That's why units are so incredibly important. I've said that since the second day of our lessons at the beginning of the year. That's why units are so incredibly important that you put on here. All right, so I'm done. This one should have been 2 sig figs, and luckily, and this was not meant, I didn't mean to do it this way, but luckily for you, your calculator should have popped out an answer with only 2 digits anyway. I believe it was 2.8 moles of NH3. 2.8 moles of NH3. Okay? Any questions there? Now the last one is where it got a little bit longer because we're going from grams to grams. I start in oxygen, I need to end in water. And there was one step in here that I didn't mean to trick you, but it got a handful of people, and I'll show you where. All right? So I start with my given, 12.3 grams of water. And I need to get out of grams of water and into moles of water. Here's another big concept that some of us missed last class, either whether you were here or not, we forgot about it. Why do I need to get into moles of water? Because my Stoich step is purely from moles to moles. I cannot go from grams to moles. I cannot go from moles to grams. I cannot go from grams to liters. Your Stoich step, when I change compounds, that's the whole point of the Stoich step, is to change compounds, has to be from moles of one thing into moles of something else, right? And so I'm currently in grams. I need to get out of grams and into moles. Well, 18.016 into 1 mole of water, right? Those cancel out. Now I'm not done. Because I'm in moles of water, I need grams of oxygen. So this is where I get out of moles of water and into moles of oxygen. There's my Stoich step. Where do those numbers come from? So here you go. What is the molar ratio of water to oxygen from this equation?
6 to 5.
Does everybody understand what I mean by molar ratio? The coefficient ratio, specifically talking about those two compounds. The first one I name is on bottom. The second one I name is on top. Right? Am I done converting this time? No. Because I'm in moles of water, I want grams of water. So now I need to get out of grams of oxygen. I need to get out of oxygen. There we go. Moles of oxygen and into grams of oxygen. Are you ready? 1 mole of oxygen equals 16 grams of oxygen, correct?
Oh my God, I put 32. Okay, 32?
It is 32.
Cool. No. Because I first put 16.
I told you guys, this was not meant to trick or to say, oh, I got you. It was just, we use oxygen all the time. All the time. If I wanted to get you, I would have used iodine or bromine, one that we bring, a diatomic that we don't use very often. We use oxygen all the time, and diatomic is still getting a few of you. So you could have done this perfectly. And if you put 16 right there, obviously your calculated answer is going to be wrong. You see what I'm saying? I believe the correct answer for this one is going to be like 18.2 grams of O. If you just put O, your unit's wrong. It is O2. 3 sig figs.
Do you have scissors? Because I put my work on here, but it's not on paper.
That's fine. Oh, yeah, I'll look at it. All right. Any